So for these, we need to figure out which one of these, sine, cosine, or tangent, which trig value is being used to solve for this missing side length. And the trick is to see which ratio is written. Because remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, lower that a little, and then tangent is opposite over adjacent. So have this handy in the back of your brain, and then we're going to solve these. So remember, so this is the angle we're focusing. Instead of calling the angles or naming them by letters, this is actually by their value or their measure. So here's angle 75. I know this is the adjacent side, right? And then this guy, because it's across the 90-degree angle, is the hypotenuse. So if I look here, x is adjacent, 39 is the hypotenuse. So we have adjacent over hypotenuse, and then if you look at the three ratios we got, that's this one, adjacent over hypotenuse. That's the cosine trig function. So I know this is cosine of 75 degrees, because cosine of 75 degrees is the length of the adjacent side over the hypotenuse. Okay? So then now, here's 67 degrees. That's the angle we want to focus on. That's this angle up here. Okay? This side is the adjacent side. Now I know the hypotenuse is over here. I'm not using the hypotenuse, so I'm not going to necessarily write it in. But then we also have this side over here. This side is the opposite side. So I know x is the adjacent side. I'm going to put adjacent down here. And then 30 is the opposite side. So I know on top we have 30. So opposite over adjacent, that's this one. That's tangent. Okay. So I know we're using the tangent trig function. So tangent of 67 degrees is opposite over adjacent. Opposite over adjacent. So here's the angle we're going to focus on, which is this angle down here. This is the 28-degree angle. If I go across this way, that makes this the opposite side, or the opposite leg. If I go across the 90-degree angle, that makes this the hypotenuse. So this is the adjacent side. We're not using the adjacent side, so I'm not going to put it in. X is opposite. 54 is the hypotenuse. Again, if you look for that ratio, opposite adjacent, not that one. Opposite hypotenuse, this is the one we're looking for. Sine. Sine of 28 degrees is opposite over hypotenuse. Okay? So we're going to do the same thing for the last three. You're not going to be able to see this anymore, but just keep that in mind. You should have that written down on your paper anyway. Okay. Actually, you know what? I'm just going to put the ratio here, and I'm going to leave this for you guys to fill in. So again, 32 degrees is the angle we're going to focus on, which is this angle. This side is next to it, so it's the adjacent side. This side is across from it, so that's the opposite side. And again, this is the hypotenuse. We're not using it. I'm going to leave it blank. But this is opposite. X is opposite. And 36 is adjacent. You write down which one it is. It's either sine, cosine, or tangent. But it's opposite over adjacent. Figure out which one it is. So 13 degrees, it's kind of hard to see this. They can't really put the 13 degrees in there because it's small. But this is the angle where 13 degrees is. It's this angle down here. Okay. That makes this the hypotenuse always because it's across the 90-degree angles. And this is x because it's across the 30 degree. It's not next to it. Next to it is down here. Okay. So x is opposite. 17 is hypotenuse. So find out which ratio, sine, cosine, or tangent, gives you opposite over hypotenuse. And then put that here. And then the last one, here's 73 degrees. This is the 73-degree angle here. This is the hypotenuse. This side is opposite because this one is adjacent. Okay. So x is opposite. 42 is hypotenuse. Okay. It's the same as this one, so whatever you put here, you better put here. Opposite over hypotenuse, opposite over hypotenuse.